Okay, so this video comes at the request of one of my students. This is Standard 4 if you are in Ms. Venable's class with me. And so it covers periodic trends, all things about the periodic table really, but specifically the request was about the trends. So I wanted to take a little bit of time to talk about those. Before I get into the trends themselves, there are a few truths that I want to talk about on the periodic table itself. This one has all kinds of marks on it, but that's okay. It'll still work. So the periodic table is this wonderful thing that gives you all kind of information about all of these different elements. And the elements that are in the same family or the same group often share similar traits. Groups in particular. A guy by the name of Moseley is the one who put the elements in order according to atomic number and discovered that in fact the properties of these elements repeated every 8 elements. He called it a periodic law, something that repeats in a cyclical nature. So these trends are all periodic trends in the sense that they repeat for the elements going across the table, and there's also trends going down. Now there are 2 truths that you need to remember about the periodic table, and these truths hold true for all 4 of the trends that we're going to talk about over the next video or so. Anytime you are talking about going down a family, since we've done electron configurations, we've talked about the fact that each of these rows on my periodic table, 1, 2, 3, 4, 5, 6, 7, those represent rings on my atoms, levels, where my electrons can hang out, or where my electrons can hang out on configurations. So each of these levels represents a ring. So as I'm going down the periodic table, I'm adding rings as I move down. Hydrogen has 1 ring, lithium has 2 rings, sodium 3, potassium 4, and on and on and on. So as I go down my periodic table, each subsequent atom has an additional ring containing electrons on it. We also have a higher number of electrons, but it's that more rings that makes the difference going down a family. And this particular truth, it pertains to all of the trends. Again, it explains everything. It's all a matter of the details that vary. So anytime we talk about a trend moving down a family, the explanation is always something to do with more rings. When we go across a row, also known as a period, as we go across here, I'm not adding any new rings. That's particularly noticeable on the first 3 rows. 1s, okay, this is 2s, this is 2p, 3s, 3p. Sorry if I'm making you dizzy, moving my periodic table around so much. I love this document camera. No new rings. Here, we're still on the 3rd ring. Even over here, I'm still on the 3rd ring, so my rings aren't changing. Once we move down here to the 4th row, I've got 4s, this is 3d, followed by 4p. So I still haven't added any new rings beyond my 4th ring. 4 is the maximum that I have. So I'm not changing my ring number as I move across a period. Instead, I'm changing the number of protons that I have in my nucleus. That's the kicker when you move across a period. More protons. We also have more electrons, and occasionally that plays a role. But the big feature that you need to remember across a period is that bigger magnet that I'm putting in the middle of my atom. Same number of rings, but a bigger magnet with stronger pull to reach out and attract those electrons on the ring around, rings, plural most of the time, around my atom. So those 2 facts are going to explain everything. There are 4 trends that I'm going to go over in the next video or so. Atomic radius, ionic radius, ionization energy, and electronegativity. And I'm hoping to go through each in turn with a handful of examples and lots of pictures. So I think we'll keep this video short. I'll go through the sections on the periodic table real quick in case you don't know. So we already said this is called a family. This is called a row or a period. this family 1, also known as the alkali metals. Family 2 here is known as the alkali earth metals. This center section is called the transition metals, goes all the way in our D block. Everything to the left of my zigzaggy line, these are the metals, and to my knowledge, this is in fact called the zigzaggy line. I know of no official term for it. But this should make sense. Copper, zinc, iron, you know these are metals. So it should be fairly obvious that this side of the line are all my metals. This side are all of the non-metals, with the exception of hydrogen, who decided he liked family 1 better. He's also a non-metal. This family here, family 17, also known as the halogens, and our last family here is the noble gases. They don't play well with anyone. So any of these families, they tend to have similar traits. Elements along the zigzaggy line here, on both sides, with a few exceptions, these are the metalloids. Think of them as metal-ish. They have properties of both nonmetals and metals. The exceptions to this rule are aluminum and astatine. Hopefully I'm saying that right. It's kind of a fun word. Aluminum is in fact a metal. Astatine is a non-metal. But polonium, tellurium, arsenic, germanium, silicon, boron, antimony, those are tellurium, those are all metalloids, metal-ish. At the bottom here we have our lanthanide series. See, there's lanthium. And our actinide series. Here's actium. Some of your periodic tables will have these two elements in front of this section, which is nice if you're trying to remember the names of those rows, but it's a pain in the big toe when it comes to doing configs because you have to remember that they're D's. But anyway, brief summary of the periodic table. Hope that helps. Next up, trends.